In this video, we will be taking a closer look at what is known as either flat pebble limestone or flat pebble conglomerate. A special thanks and a shout out to Lithic Beads, my subscriber who clarified in the previous video about the rocks from the Little Bighorn River that I posted recently of the origin of this material and also what it is called, because I was not sure. I actually have quite a large and varied collection of this material from quite a few different places, so stick with me as we explore some truly amazing and colorful rocks. The rocks at the very beginning of this video are the same rocks we saw in the Little Bighorn River video posted recently. This first batch of rocks we're seeing now are from near the small town of Lysite, Wyoming, which lies just south of the Wind River Range in the central part of the state. I came across quite a bit of technical research that people have done, and it was fascinating. Most of the words are beyond my vocabulary and pay grade, but long story short, the material forms in shallow sea environments where limestone is actively depositing, and violent storms that are strong enough to break up the recently deposited layers and tumble them around, sometimes to where we can't recognize where they came from, and sometimes they just break and kind of lay in the same place. And when you stop to consider how large the inland sea that covered much of North America was, and how it varied in size over the eons, it makes sense that this material would be as widespread as it is. Just in this video, we will be looking at rocks that come from basically a large part of the state of Wyoming and into Montana. As you can see, I brought home several very large pieces from the Lysite area, and they were on a hillside and they had weathered in a really interesting manner. They kind of camouflaged in and amongst the sagebrush. From what I understand, it is largely due to the presence of diatoms and other microscopic sea creatures that accumulate on the seafloor, whose exoskeletons are made of silica. So often there is an abundance of silica present within limestone, resulting in either layers or nodules of either flint, chert, or jasper. Those three are basically distinguished by the amount of impurities within them, but they are all silica. And in some cases, whole areas within the limestone layers are replaced with silica, conserving the original patterns and textures of the stone that was replaced, perhaps in a manner that is similar to what happens in petrified wood or petrified bone, where silica replaces the original material but conserves its appearance and colors. So in this area not far from Lysite, various layers within the flat pebble limestone were silicified. These pieces that we're looking at here are Jasper. They are very hard and good for making cabochons and jewelry and things of that nature. In fact, we have found similar material for sale online known as bamboo jasper, and so we have affectionately dubbed this material Lysite bamboo jasper. Here are a few photos courtesy of my friend Grant over at Talking Rocks, Lapidary, and Jewelry, which can be found on Facebook. These are, of course, made from the material collected near Lysite. Okay, from here we'll take a trip north into south central Montana to the Yellowtail Dam and the Bighorn Canyon National Recreation Area, which is a really long, winding canyon filled with a lake that's held back by the dam across the Bighorn River. A huge thank you and shout out to my good friend Art, who has taken me to this lake a couple of times. Here are some photos from one of those trips. And at a certain point along the shore, we were able to pull right up to the shore, and there were all these beautiful green flat pebble limestones there for the picking. So we grabbed 3 or 4 of them to take home. These are interesting because the colors aren't very vivid, and yet they do have the pattern. Here we're looking at one where the pebbles are really small, which is kind of unusual. A trip along the 50-mile or so course of this canyon gives an amazing perspective of the thousands upon thousands of feet of sedimentary and other rocks that were uplifted during the Laramide orogeny in relation to the Bighorn Mountains and other uplift blocks. Now we will go west to the area around Cook City, Montana, near the northeast entrance of Yellowstone Park, where we find yet more flat pebble limestone, among other fascinating rocks. Most of these came from the Clark's Fork River, south and east of Cook City, although a few of them, and I'd be hard-pressed to tell you which ones, came from Cook City's own Soda Butte River. I do remember that this material is much more abundant in the Clark's Fork River, though. A side note for you who do lapidary: many of these river cobbles are bumpy and fractured, and you can tell they wouldn't be much good if you were to work on them. But some, such as this one, and most of the ones I have in my collection, are very smooth and dense and have eroded very evenly, which means they have a consistent hardness all the way through. I would imagine it would be similar to polishing marble or, again, limestone, which it is, which might be great for some applications. I would be curious to read in the comments if any of you have worked with this material and what you have made. Over many years and on different occasions, we've gone to a lot of different places, quite a few different creeks and canyons in the Absaroka Mountains and the Beartooths and all that area around Cook City, and most of the creeks have at least some of this material. And over the years, I have been able to collect quite a bit of it, and some of the pieces are quite colorful, such as this red one you're seeing here. I actually cut and polished it. This, I believe, was actually from the little creek there right in Cook City, behind the town. I believe it's the Soda Butte Creek. They're kind of rare in that creek, but they do show up. This one here, I believe, is from the Clark's Fork. Again, very solid. You can see it eroded quite evenly. Very vivid colors. This is, all in all, amazing material. And for as common as it is, at least in my experience and my world, I'm surprised there isn't more information about it because of how attractive it is. But I'm glad I finally know what it is. And here's one of the really big ones we brought. The color isn't very vivid, but look at the pattern on this thing. It's all the way around. In fact, I ground the bottom off and was going to polish it, but for the same reason that it really has no color at all, it's still just in the ground phase. Maybe I'll finish it off one of these days. I do want to insert a side note here about the colors and patterns. Why are there so many wild colors and patterns in this material? Well, it's technically called a tempestite, which is a rock resulting from tempests or storms. It's directly related to storm activity. And of course, you know, when limestone is forming in a marine environment, it's a very calm environment. A gentle light snow of marine organisms settling on the seafloor and hardening into these layers. But then a storm comes along. They can be very violent, and rivers are gushing into the ocean with all kinds of nutrients and mud and sand and sediments. This rock here really shows the violence. Can you see the color and pattern of the infilling material? It's obviously coarser, and you can see the layering as it was shoved in between the pieces. So I think it's the same violence of these storms that brings such a variety of both solids and dissolved minerals and the like that causes the wild array of colors and patterns we see in this rock. I'm not sure if these are originating from flat pebble limestone or not. The clasts have obviously been dissolved, but they are from a limestone environment in the Pryor Mountains, south of Billings, Montana. Let me know your thoughts on these in the comments, and thank you for joining me. Please like, share, and subscribe.